Quantum mechanics, the strange world of very small things. Imagine shrinking down to the size of an atom. Weird, right? That's quantum mechanics for you. It's like a funhouse mirror of reality. In the quantum world, particles can be in two places at once. They can tunnel through walls, and they can even communicate faster than light. Think of it like meeting the actors of your favorite TV show, but instead of actors, it's particles. Now you might be wondering, why should I care about something I can't even see? Well, these tiny particles are the basic building blocks of everything. Understanding them helps us understand the universe. Let's dive in. Alright, let's talk about fermions. These particles are named after an Italian physicist, Enrico Fermi. Fermions are like the introverts at a party. They prefer their personal space and don't like to share. No two fermions can occupy the same quantum state at the same time. This is called the Pauli exclusion principle. Imagine you're at a concert. The seats are quantum states, and the fermions are the audience. No matter how packed the venue gets, you'll never find two people sitting in the same seat. Some examples of fermions are protons, neutrons, and electrons. Without the Pauli exclusion principle, atoms would collapse, chemistry wouldn't work, and we wouldn't exist. Now let's meet the life of the quantum party, bosons. Unlike their unsocial cousins, fermions, bosons love to hang out together. They're the more the merrier type of particles. Any number of bosons can occupy the same quantum state at the same time. Think of bosons as the ultimate crowd surfers at a rock concert. Some examples of bosons include photons, particles of light, gluons, which hold quarks together in protons and neutrons, and the famous Higgs boson, the God particle, which gives other particles mass. Light is made of these party animals. Every time you turn on a lamp, you're basically throwing a boson rave in your living room. The sociable nature of gluons is what keeps protons and neutrons from falling apart. Without the Higgs boson, we'd all be massless particles zooming around at the speed of light. Section 4. Leptons, the lightest particles of the quantum realm. Now, let's chat about leptons. These particles are like the featherweights of the subatomic boxing world. The name lepton comes from the Greek word leptos, meaning small or thin. But don't let their size fool you. They pack a punch. Leptons are a type of fermion, which means they're also part of the "I need my space" crowd. The most famous lepton is the neutrino, which you might remember from high school science class. Neutrinos are like the ninjas of the particle world. They're so small and interact so weakly with other matter that billions of them pass through your body every second without you even noticing. Section 5. Why these particles matter. The basic building blocks of everything. So we've met the actors of our subatomic play, but you might be wondering, why should I care? Well, these particles are the basic building blocks of everything in the universe. From the device you're reading this on to the farthest galaxy we can see with our telescopes, it's all made up of these tiny particles. Understanding fermions, bosons, and leptons is like having the ultimate Lego instruction manual for the universe. Fermions make up all the matter that we can see and touch. Bosons are force carriers. They're like the cosmic glue that holds everything together. Without bosons, the universe would be a very boring place. And let's not forget about leptons. These light particles play an important role in radioactive decay and nuclear reactions. And remember, as I mentioned in the video explaining quarks, they exchange bosons, leading to weak and strong nuclear forces. Studying neutrinos helps us understand some of the most extreme events in the universe, like supernovas and the birth of black holes.
What if you could catch all our latest videos with just a click? Smash that like button and subscribe now for more awesome content.